Hello everyone, welcome to the next lecture of our blockchains course on architecture, design and use cases. So this next lecture is going to be about some of the basic blockchain components and concepts and how some of these components interact with each other. So this will give you the foundation for us to go deeper in and learning about Hyperledger Fabric itself and how it's architected. Who are some of the actors in a blockchain solution? There is a blockchain architect who is going to design how this blockchain solution is going to be built. He will figure out what are some of the information that needs to get stored, what are some of the transactions and the business logic that needs to be embedded onto the network, how the network itself should be created, and so on. There is a blockchain developer who is going to take what has been architected and they're going to develop the actual code that will run on the blockchain network itself. There will be a network operator who is going to manage and run the blockchain network. There may be traditional processing platforms. There may be other systems of record that the blockchain connects to and might get information from and send information to. Those are traditional processing platforms. There could be data sources. There could be external databases that are also part of the overall solution. So those are part of the overall solution as well. An important component here is membership services. So the membership service defines or provides the identity for users to come and transact on the blockchain. So think of it as when you open an account with the bank, they give you a username, password, a kind of a login, right, for you to access web services. Or when you get an account with Gmail or something, you get a username, password. The membership service is actually going to do a little more than that. It's not just a username, password, but it's actually going to give you a certificate a digital certificate that will allow you to transact on the network. So we'll talk about some of those details as well. And there's a blockchain user who's going to perform the business transactions on the blockchain. So these users could belong to multiple organizations that are participating in this blockchain network. And optionally, there can also be a regulator. The regulator might have read-only access onto the network, where they have some oversight into whether the transactions being performed are legitimate or not, whether they are compliant with policies set by the regulator. So all that can be done in real time with a blockchain platform. And I talked about some of the actors here, right? So this again lists the same set of actors. I think the key ones to remember are the architect, the developer. So some of you who are students who are trying to build a first blockchain project, you are probably going to play the role of the architect and the developer. You might also play the role of a network provider. So you might set up the network yourself. We'll look at some of those examples. You'll be setting up a membership service. So this could be, again, a separate organization that provides this membership service. So those things are possible. So all of these can be distinct users. But it can be one user or one organization can play multiple roles as well. So what are some of the components of a blockchain solution? Right? So we talked about some of these components, but I think it's worth going through some of them again. So there is a ledger. So every node in the blockchain network, so this is a peer-to-peer network. So every node in the network is going to maintain a ledger of all transactions. And these transactions is going to somehow maintain the state of the data that is being stored on the blockchain network. So this is going to be maintained at each peer. There's a notion of channel we'll talk about, but think of the ledger as storing all the state information. It's replicated across all the nodes in the network. The smart contract is the business logic that I mentioned about. You can encode your own business logic as code, as functions. And each invocation of this function becomes a transaction on the blockchain. So those are smart contracts. There is a peer-to-peer network. We talked about that. A membership service. So this is going to provide identities for the users to transact on the blockchain. And an important notion is the notion of events. So whenever a transaction happens on the blockchain, you can create an event notification. So the blockchain will tell you that this particular transaction has committed. It will give you the details of the transaction. And you can use that to integrate with existing systems of record. So you can use that to trigger some other transaction that might be internal to your organization. So all that is possible. So we'll see examples of how to use some of these events as well. There's going to be notions of systems management. So this blockchain network is a distributed system. It's actually running across multiple organizations. So it requires new ways to create, manage, and monitor these applications. So you're going to be monitoring at the system level, at the application level. There's a lot of interesting system management questions to be answered. There's a notion of wallet. Each user, as I mentioned, has a digital certificate, and it's going to be performing transactions using those digital certificates. And there needs to be a place where the user can securely store that private information. So that digital certificate contains the private identity of that individual. No, he shouldn't be sharing that information with anybody else. And that is securely managed in a wallet. And I talked about systems integration. Now let us look at some of these concepts in a little more detail. Now the ledger consists of, you can think of it as two important data structures. The first data structure is what you would call the blockchain itself. So this is the append-only log of all transactions that have happened. So you can think of it as a linked list of blocks. And a block, as you know, is a group of transactions that have been put together. And when I say a linked list of blocks, how are they linked with each other? There is a hash that is computed on each block that is part of the next block. So this is actually a hash chain. This is very similar to how Bitcoin also builds its blockchain. So every block of transactions there's a hash of it that's computed, and that hash is added onto the next block. So that is a hash chain that is getting created. So this is a pictorial representation. It connects transactions together, but all these blocks are also chained together. And this hash chaining gives you some certain properties of immutability, right? If you modified or tampered with a previous block, then the hash on the next block will not match. So it'll be very hard for someone to tamper with previous blocks. And also the fact that these blocks are maintained in a decentralized fashion means that you'll have to take down or manipulate a large number of nodes in the network, a large fraction of nodes in the network, to be able to tamper with this. So it gives you a lot of immutability properties. So that is the blockchain aspect of the ledger itself. So this is the sequence of transactions that every node in the network is going to maintain. The second data structure is the world state. So what is the world state? So this is the information that your smart contracts can work with. It stores the most recent state of smart contracts that are the outputs of transactions. So in the Bitcoin world, you can think of the world state as maybe like the account balances. So the fact that this particular user owns so many Bitcoin, the Bitcoin blockchain does not explicitly store that, but because of the fact that we are looking to handle much more generic smart contracts, we allow the ability for you to maintain arbitrary state information. So these are all stored as key value pairs, and we have other databases support as well. But this is, think of it as you're going to store some state on the database. Each transaction is going to manipulate this state, and the output of transactions is also recorded on the blockchain. Right? So the transactions include what state was read and what state was written. Right? So that is the world state that's also going to get maintained. The other way to think about the world state is think of the blockchain transactions as modifying data over a period of time. It keeps modifying this data. The world state, think of it as just the most recent view of the blockchain itself. The historical values are all there in the blockchain, but the most recent values of every piece of information you're storing is stored in the world state. And this allows you to add, modify, and even delete elements. So you can go delete an entry in the world state. What this means is a new transaction gets added, which marks this data element as deleted. The previous fact that a data element was created, modified, are all part of the blockchain. That cannot be tampered with, but you can go add another transaction that says this element is now deleted, which means that any transaction that tries to operate on this deleted element will fail because this element does not exist anymore. But the record of all previous transactions, even on the deleted element, all the previous transactions up to the point it was deleted, will get recorded on the blockchain. So this shows the block itself in a very simplified format. What are some of the aspects that you are going to store in the block? Like I mentioned, every block has a hash, and this hash is getting chained together. So block 15 has a particular hash, and that hash is getting stored in block 16. Likewise, block 16, there's going to be a particular hash, and that hash is in block 17, and so on. So that is the hash chain itself. Apart from that, the block is a sequence of transactions. It's a set of, each block can have multiple transactions in them, and that each transaction is going to say which smart contract got invoked, what was the specific function that got invoked, which user invoked this transaction. There will be some notion of their identity which will be there in the transaction. There will be other details as well that are part of the transaction. Right? So all of this gets embedded into a block. Each block can have 0 or more transactions. The reason I say 0 transactions is the very first block that you're creating in the blockchain is called the genesis block. So that has special information about the configuration of the network itself, who the participants are, and certain other configuration information. So that genesis block does not have any user transactions. So for that reason, it could be 0 or more transactions. But all the other blocks in the blockchain will have multiple transactions. The immutability, like I mentioned, is achieved because of 2 properties, because of the hash chaining and also because of the fact that these blocks are getting added through consensus in a decentralized fashion. So no one single organization can unilaterally manipulate this blockchain itself. So here is an example of the ledger itself and how a transaction might work. And for familiarity's sake, we are going to pick just the transfer of ownership itself. This is just the kind of transaction that Bitcoin does. So we're going to take the same example, but transactions can be much more complex and can manipulate arbitrary data elements like I mentioned. Right? So let's take an example. So here is a smart contract. It takes as input down here. Here's a smart contract that takes as input, let's say, a particular owner. We are going to take a car, for example, and we are going to set the owner of that car to Matt. Right? So there is a set owner function. So this is a very simple smart contract function. All it does is it sets the owner of the car to a new person. So the new person in this particular example is going to be Matt. So what are some of the inputs to this function? The input is basically the car itself, so the car data element, and the owner of that car, right? The new owner of that car. So these are the 2 inputs to the function. And what you are setting is that the car element itself is getting modified. So the car.owner is getting modified to new owner. So that will be the final output of that transaction. So this car object has been modified. Now, if you look at the world state, now the my car is now set with these elements. So this is how the my car object has been modified. So this is getting stored in the world state. The transaction that contains this information saying this particular contract was invoked and these are the arguments for that contract. This was the output that got written from that contract. All of this gets written as a blockchain transaction in the blockchain. Right? It's one of the transactions in the block. So now let's look at how external applications could interact with the blockchain ledger. So what are some of the key things? Right? So there's a blockchain developer. It could be you and me. We are developing both the client application that will interact with the blockchain, and we are also developing the smart contract itself. So this is the business logic that runs inside the blockchain in a decentralized fashion. So in the previous example, that set owner function was this part of the smart contract, and that's the one we are writing. And there's a client application that's going to invoke these functions over a period of time. So the client application is going to be the one that says Matt is now the new owner of this car, and we're going to set Matt as the owner. So we invoke that smart contract with those elements. So the client application will use an SDK to submit transactions onto the blockchain. And the client application can also separately access the blockchain directly to see whether those transactions are actually committed, or also look at historic transactions. So you can go and ask, give me all the transactions that happened in block 40. Or you can go and ask, for this particular car object, tell me all the changes it has gone through over a period of time. Right? So you can get all that history back from the blockchain. Like I said, every transaction that you're invoking gets recorded on the blockchain, and all the elements that are getting modified, whether it's a read, it's a get, or it's a write, we call it a put, or it's a delete. So whatever you're doing on the data elements will get recorded onto the world state, and parts of the world state are whatever is getting modified in the world state is going to be part of the transaction. So that's how the blockchain itself is constructed. And this is all, if you see, all of this is part of one peer, which means that every peer in the network is going to be performing this function. When the client application submits this to the smart contract, that smart contract gets executed on all the nodes. all of the nodes simultaneously will update their world state, will agree that this output is actually valid and this is all consistent across everybody, and then the block will get added with that legitimate transaction onto the blockchain. And once you commit that transaction onto the blockchain, in the enterprise setting, we're going to call that a final transaction. So unlike the Bitcoin world, forks in the blockchain can happen. In this world, there is only going to be one serial sequence of transactions and blocks. There can never be forks. And this sequence is, once it's written onto the blockchain, it's final. No one can change it. And there will be, you can get an event emitted out of it saying this transaction has now simultaneously been committed on all the nodes in the blockchain, and an event can be generated. Now you can use this event in however way you want. Right? So this can be used internal in an organization to perform additional processing that organization needs to perform and so on. Right? So those things can be done. So the events, again, I think I've covered most of these aspects. I think the important aspect here is these can all be used for asynchronous processing. We don't have to wait for the blockchain to commit. So when the client application submits a transaction onto the blockchain, it might take a few milliseconds, few hundreds of milliseconds in the enterprise world. We don't have to wait even for that amount. You can be doing your own processing otherwise for other purposes. And you can get an event back from the blockchain to say this event has now committed. So that allows you to process things in an asynchronous fashion. You don't have to wait for the blockchain to commit. And using those events, you can perform additional processing. And this event will tell you also, even if the blockchain, if the transaction was rejected for any reason. It could be rejected for a multitude of reasons. It might be that the user who performed this transaction was not authenticated or did not have the right access permissions to perform the transaction. Or it could be a host of other reasons why the transaction may be invalidated. And you'll get that information as well in the event. If it was rejected, the application can always try to perform that transaction again if it feels that it's a legitimate transaction. You can also integrate other applications to trigger blockchain activity directly. For instance, you can connect an IoT device to a blockchain. And whenever the IoT device, or let's say a gateway, detects that, let's say, there is a serious event that needs everyone to be aware of, then it can automatically perform that transaction on blockchain and can get a confirmation back through the events saying everyone has now been apprised of the fact that this event happened or this particular transaction has been committed. So this blockchain events is central to integrating with existing systems. And when we look at some of the solutions we are building, it'll become apparent why integrating with existing systems is such a key factor, key part of enterprise applications. Right? Blockchain is never going to be operating by itself in a silo. It is definitely going to be integrating with existing systems in each of the organizations that are participating in the blockchain network. And the integrations can both be in terms of sending information to blockchain as well as getting information out of blockchain. So that's the two-way exchange that is explained here. Okay, so with that we come back to our fun reading section. So hopefully you've got some of the basic concepts and components of a blockchain platform. And here there is some interesting reading that you can look at. So there is a nice white paper by Infosys on how you can integrate some of your ERP systems in an enterprise with a supply chain. It explains some of the importance of integrating systems and how you can automate some of these processes that were all manual previously. In the enterprise world, companies have done very well in automating their internal systems. But when it comes to interacting with enterprises outside of their organization, with other enterprises, then a lot of the things break down to manual processes, paper documents, and so on. And blockchain uniquely enables you to automate some of those cross-organizational processes, and some of these integrations are pivotal to that. The next one is an introductory video to Hyperledger Fabric. It's only 3 minutes. So over the next 4 lectures, we're going to look at Fabric in quite some detail. We'll also go through some demos of Fabric itself. And here is another video explaining some of the concepts in Fabric. So I encourage you to look at some of these videos, and we'll meet again at the next lecture to delve deeper into Hyperledger Fabric. Thank you.